Hello, I'm gonna solve number 56 merge intervals. Okay, let's read the problem. Given a collection of intervals, merge all overlapping intervals. Let's see the first example. Input data is 1, 3, 2, 6, 8, 10, 15, 18. The output would be 1, 6, 8, 10, 15, 18. Because 1, 3 and 2, 6 are overlapped, and the remaining 8, 10, 15, 18 intervals are not overlapped. So 1, 3 and 2, 6 is merged into 1, 6. In the second example, input is 1, 4, 4, 5. So the output is 1, 5. That is the merged interval. Intuitively, we can think that we should find the solution faster than the n-squared time complexity. Okay, let's see the diagram down below. I try to depict intervals sorted by endpoint, and then we could use the line sweeping algorithm from the left side toward right direction and check if the endpoint is overlapped by the starting point of next interval. But the problem of this algorithm is that next interval sorted by the endpoint could encircle the previous intervals by the smaller starting point. I just pointed this case using green color. In this case, we should merge the previous intervals. To check all these cases, we can implement our code in O(n) time complexity. We should finish the merging operation in a single iteration. So with this example, we could know that sorting by endpoint is not appropriate. To prevent this problem, let's sort the intervals by ending point. Okay, let's see the diagram of intervals sorted by starting point in the right side. In this case, as you can see, previous encircling problem is not happening here. So generally speaking, if you iterate from the left side to the right side to find merged intervals, you have to use the array of intervals sorted by the starting point. If you want to go backward, just like going from the right side to the left side, you have to use the interval array sorted by ending point. So in the previous picture, you have to iterate backward. Okay, let's see the code. Okay, this is the implementation of previous algorithm that I explained using sorted interval array by starting point. As you can see, sort algorithm is used, provided in STL library. Sorting condition is A0 is smaller than B0. This means we like to sort interval array by starting point, and then we iterate the sorted array. Okay, let me explain the MI. MI is the integer array representing the current merged interval as the iterator I moves. MI is updated into larger intervals by overlapping neighbor intervals. This is the condition checking overlapped intervals. I just marked in green color in the diagram. At the beginning, the MI is initialized with the first interval. As you can see in the code I just marked, and then compare MI's ending point with the next interval's starting point. If the condition is satisfied, we have to update MI for its ending point with a bigger value by comparing the MI's ending point and I's ending point. This is to consider the encircling case, as you can see in the diagram, marked in purple color. And then MI is not overlapped anymore. We should push the MI in answer vector. And the last MI also should be pushed back in answer array after finishing for loop, and then return the answer array. Okay, this code is O(n) time complexity, performing faster than 94.44%. Thank you for watching. See you next time. Bye bye.